Hi, I'm Greg, the developer advocate at Hedera Hashgraph, and this is the second part of our API.
Right, everybody, we're back. Features of the file service are its asynchronous Byzantine fault tolerance, proof of deletion. We touched on GDPR sort of requirements earlier today. Once a file has existed on the network and it has been deleted, we can prove, or Hedera can prove, that it has been deleted indeed, or give you proof that that's been the case. Files have a time to expiry, meaning that, I joke about this, but if you work for Mission Impossible and you're given a mission in a file, then it could self-destruct after 5 minutes. That's what time to expiry means. So the network will automatically take care of deleting the contents of a given file by that time, and then you can get your proof of deletion, which won't be as explosive as what we see in the movies. Files can have WACL or write ACL keys. So I touched on control mutability earlier on, and this is one of the areas where this prevails. So what do we mean by write ACL keys? Well, if you create a file on the Hedera file service, you can attach to that file one or more keys. So again, a single key, key list, threshold keys, nested key structure, however you see fit. And what that means is that if anybody, or if anyone ever needs to delete the file, update it, or add contents to the file, or change any of its properties, then the transactions for doing so have to be signed by the access control list keys. So this is control mutability, and the file is mutable, but only under the control of the key holders. So if, for example, I think I talked earlier about a contract between my employer or an employer, I won't refer to mine here, an employer and an employee, it's entirely feasible that the contract between those two could be stored as a file, or a hash of that contract could be stored as a file on the network with both the employer and the employee's keys associated with that contract. Meaning that if any party wants to change the contract, they both have to approve the change. It can't unilaterally be changed by one or the other party, unless there is a threshold key and a one of two is set. But if the two keys exist and they're both mandatory or required, then the two parties have to sign. So the file is mutable, but under control of the parties who have an interest in it. It's not a free-for-all where a body or otherwise you have a contract with is able to modify the contract and not necessarily tell you about it until it's too late. So that's what ACL keys are for. If you wanted an immutable file, you can create a file without any keys, and then it's immutable. It will exist until it's time to expiry. It will exist for as long as it's being paid for, but it can't be modified because there are no keys to modify it with. So immutable files are a possibility if you don't put any keys. That's up to you. Small sizes, again, this is related to the cost of storing files on Hedera Hashgraph. It's expected that for a given size, it will cost more than the more traditional file storage capabilities. So the recommendation or the expectation is that the files stored on Hedera Hashgraph will be relatively small. And I've talked earlier about storing a hash of a file and storing the file itself in a different location or in as many locations as there are interested parties, and then using the hash as proof of the file's existence and of the file's contents in case of a dispute, rather than storing the file itself on the network. Transactions, we can create, append, delete, and update files. sensing that I've got slides on all of this coming forward, so I've done my usual trick of jumping ahead. So let's jump ahead. So files are copied and stored on every node in the network. It's not a peer-to-peer with distributed fragments, and it's not just 2 or 3 copies for safety. They're not stored in a standard file system, and they're therefore tamper-proof. What I mean by that is a systems administrator can't go and find your file in a complex directory structure on the file system and decide to delete it or remove it or modify it. It's in a Merkle tree hidden in the depths of Hedera Hashgraph and not accessible to anyone without the keys. So the files themselves are safe. Having said that, the council does have the ability to delete a file if it is deemed to contain inappropriate content. So when I say can't be deleted by anyone, it can be deleted by the council, but this would likely be with heavy controls in terms of all the council members having to sign, or a 2/3 majority of council members having to sign the file deletion. So this is not something that's being taken lightly. We feel it's a necessity in order to protect the network moving forwards, but it's not something that is being seen as a means to I'm going to say tamper with data. If anything, only deletion is available. Modification is not. So the file remains immutable in contents, even if the council, the council can't delete it. Sorry, can't modify it. Can only delete. GDPR, again, one of the issues maybe with a number of platforms out there, and the notion of immutability, is that the reality of this world is such that we as individuals require that our data is stored sparingly, and GDPR has a number of requirements around storing required and necessary data. So the color of my hair is not necessarily relevant to my banker, so they shouldn't ask for it, and that's part of the GDPR regulations. But moreover, if I want my data deleted, and there is no reason why that data should remain on the system, the holder of that data has no justification for keeping that data, then they should be able to prove to me that they've deleted it at my request. Hedera provides you the ability to delete a file, all under control mutability constraints. So all the keys have to sign for the deletion. And Hedera will be able to prove that once deleted, that file has indeed been deleted. So a state proof, for example, will give you the reassurance that the file was indeed deleted. And therefore, your app, if it's using Hedera, will be GDPR compliant in the context of deletion. Obviously, storing appropriate and necessary data is your responsibility, not Hedera's. So yeah, it's a complex minefield, this GDPR thing, but Hedera can delete, and that's a significant part of it. So yeah, so I've sort of covered the storage fees to a certain extent. It feels if files were free to store, there is a risk of tragedy of the commons. I'm aware that there are platforms out there that allow you to store files for free, and they may continue to exist for a long time, or they may struggle or suffer from tragedy of the commons, where, let's face it, we live in the digital age where we're increasingly creating more and more data and putting it in various places, be it photos or something, and not necessarily going back to delete it. So so my guess is that free file storage will probably end up being polluted with lots and lots of unnecessary data, and there will be a cost associated with doing so. So it probably won't be free forever, or is probably not sustainable. Hedera has sort of a more upfront approach to this. There is a cost for doing so, or there is a cost for storing the files, and we therefore expect whoever wants a file stored to pay for it. So if a file is created, it's created with an expiration date that will be used in conjunction with the size of the file to calculate the service fee for storing the file. And if the file's expiration date is not updated over time with the appropriate payment for the extension, then the file will automatically be deleted. So the system will prune itself, if you want, and only keep relevant information if files are not being extended by their owners. So deletion of file, it's under control mutability. Changes can only happen if signed and approved by all the key holders. I've covered this already. And a file can be created without keys, which would essentially, or which not essentially, would make it immutable at that point. And it will just expire over time. So creating a file with a file create transaction enables you to create a file by uploading the contents of the file. It requires an optional key or keys, an expiry time, and some contents. There's a note here, a Hedera transaction is limited to 4 kilobytes. It may turn out to be a little bit more than that, but at the moment I believe it's 4 kilobytes, including signatures, and that's for the whole message. So if your file is greater than 4 kilobytes, and arguably greater than, slightly less than 4 kilobytes, allowing for the complete message and signatures, you will need to append to the file. And what that means is you've created the file in the first place with your first, say, 2 kilobytes of data, and there's another 1 to add. You run an append transaction, which will add the extra 1 kilobytes to the contents of the file. So the SDK, as an example, the Java SDK, has an example around file creation. You can give it any size payload, and it will chunk the payload, and it will run a create transaction followed by as many append transactions as necessary to store your file on the Hedera file system. Okay, so that's file append. File delete, well, guess what? Deletes the file. It leaves the metadata on the network until the expiry date, and this allows Hedera to prove, or you through Hedera to prove that it has indeed been deleted. So the metadata is everything about the file except for its contents, which have been deleted. And a file update transaction allows you to update file properties, such as the expiration time, which you can extend. So there will be a cost associated depending on the size of the file and the duration of that expiry. You can change the keys. So per an account, if you change the keys of a file, the original key holders have to sign and the new key holders have to sign to make sure that the file isn't lost to a key mistake. And the contents can also be updated, bearing in mind that this overwrites existing contents. There is no possibility to update the 200 bytes starting at index 55. When you update contents, you update you update all the contents at once. And if the content update obviously was more than allowed by transaction size, you would have to do a first update followed by a number of appends that contain the additional information of the contents. So a file creates, as seen through the lens of protobuf, we can see an expiration time, which is a timestamp, a key list, which is a list of keys or single key, contents as a byte array, and the shard, the realm, and the realm admin key that you want the file created under. So again, if you specify an existing shard and realm number, that's where the file will be created. If you specify a null realm ID, then a new realm will be created with that new realm admin key. But again, this is all kind of not yet available on Realms. File append, so you identify the file ID. So the file ID is the realm, the shard, the realm, and the file number, which will be returned to you when you create the file, and the contents that you wish appending to the file. And that's about it for files. So we'll move on to smart contracts. So smart contracts have a gas feature. Like other platforms, you need to specify how much gas you're willing to pay, and we'll cover gas in more detail in the subsequent slides. An initial balance, if it's payable, the smart contract that is, the proxy account for the smart contract to proxy its currency to. An auto-renew period for the smart contracts, whether you want to run a particular smart contract function on a single node rather than the entire network. And again, we'll explain what, or I'll explain what this is all about. Administration keys for a smart contract, we're back into control mutability. So again, we'll look at what that means moving forward. And then transactions and queries, similar pattern to accounts and files. So, gas and gas price for smart contracts. Hedera is fair, or Hedera wants to be fair. So, in Hedera Hashgraph, when you run a smart contract function or you create a smart contract in the first place, you specify an amount of gas, which is essentially setting the limit on how much you're willing to pay to execute that particular function. So if you say 10,000 gas and it requires 15,000 for your contract function to run, then your smart contract function will fail to execute fully because it was missing 5,000 gas. That's and that's necessary. You could say, well, just make it 500,000 and then, never mind, because Hedera refunds any overspent gas. However, if your function was to run into some sort of infinite loop or something that would essentially means it will just continue consuming all of your gas up to 500,000. And then you're left with a function that hasn't succeeded because it's eventually run out of gas. You spend 500,000 and that clearly is no good because you need to run it again, arguably under different conditions to make sure it doesn't run into this infinite loop again. So gas on Hedera Hashgraph is a limit. Anything you've overspent is refunded, and anything that's insufficient is, on the other hand, fully spent before the transaction fails. Fully spent, well, yeah, because you've used resources to get to the conclusion that you didn't spend enough. So that has to be accounted for in terms of resource utilization. So unfortunately, if the gas amount is insufficient, it will be deducted from your account and the transaction will fail. Gas price is the exchange rate between gas and HBAR. Nothing new here, except it's set network-wide. It's not set by individual nodes. So no node has the ability to set its own gas price. The network as a whole will have the same price, and the council will decide what a reasonable gas price is. So as long as gas is sufficient to run a function, a node cannot reject the request. A node will receive your function or your request to run a particular function. It will validate that the transaction request is correct, and it will send it to the network for consensus. And if it turns out that gas was sufficient, then the smart contract function will execute in consensus order, not in descending gas order or any other weird and wonderful way of I'm not including your transaction into the next block because the gas amount you specified isn't worth my while, or any of those things. Or I'll put it at the top of the block because your gas amount is higher than everybody else's. That's not fair. neither in terms of order of execution or fairness of access. If a node can refuse to run or include a transaction to a block because I haven't paid enough, then that's not fair access. So that's why I spent some time on gas and gas price. It's I feel different enough to how it's normally used to warrant spending some time covering it. So the initial balance of an account, which is created with a smart contract. So when a smart contract is created, a Hedera account is created for it, and that account potentially needs funding if the contract is payable. So the initial balance only applies to smart contracts that are payable. If your smart contract is not payable, there is no need to specify an initial balance. Because there's no well, in fact it will fail. Only payable contracts can receive an initial balance. The auto renew period for a smart contract is exactly like an account. A smart contract requires resources to exist, and it will renew itself every 3 months, 6 months, 6 hours, however often you want. It will charge its own account, which is created at the time of contract creation for that renewal period. And if the account hasn't got enough funds for the entire renewal period, then it will renew itself for whatever proportion it can afford as per a normal crypto account. Likewise for proxy, a smart contract can proxy its accounts coin to a node account if it wishes to do so, and it will earn interest as a result. So another feature of smart contracts on Hedera Hashgraph is the ability for a one node call. It's a contract call local. That's actually a query rather than a transaction. And it enables a view or read-only function, non-state affecting function, to be executed on a single node rather than the entire network. So as you know, queries are not sent to the network for consensus. They're run by or responded to by a node alone. So if your smart contract function only reads the state of a contract, be it an internal variable or otherwise, but has no impact on or makes no modification to the contract state, then you can run a contract call local query. What you'll get is efficiency gains because it will not go to the network, so it will be cheaper than running a full function that goes to consensus and runs on every single node. You'll get an immediate response. There is no consensus delay of a few seconds while the network reaches consensus. The node can tell you straight away, X contract has X amount in its balance or X value in this variable. So all of that comes to lower cost and much more efficient. So make use of the contract local call query if you have read-only functions, and your application will be all the more efficient for it. Admin keys. Just like files, if the admin key is null or not supplied, the smart contract is like any other, it's immutable. You can't later add an admin key to a smart contract that was created without one. So once it's created without a key, it remains without a key until it expires. On the other hand, if the keys are set, then the key holders are able to modify a smart contract that is running. They can modify the state of the instance, they can modify field values, they may be able to modify the bytecode. I'm not entirely sure on that one, and it's not yet implemented. I guess we'll have to wait and see until it's available to see clearly what we can do. But the point here is that mutability of a smart contract is a possibility with Hedera Hashgraph under control of keys. And if you wanted to check or be sure that the smart contract you're about to execute a function on is immutable because that's your preference, then you can do a get info on the smart contract and it will tell you what keys are associated with it. Equally, if you want to check who owns the smart contract and who has access to it, then a get info query will give you those keys, and then presumably the author of that smart contract will publish who they are in order for a trust relationship to exist. I guess there are people I would trust to have administrative capability over a smart contract, and there may be others I won't trust. And that may help me determine whether I want to run a particular smart contract or not. So control mutability, again, we feel it's a necessity in today's world and for adoption by a sort of broader community. And that's all controlled through keys. A smart contract without keys can no longer or can never be added keys to, and a smart contract with keys can only be modified by those key holders. And presumably the admin keys can only be, again, modified by signing with the old keys and signing with the new keys, just like files and accounts. So a couple of other things on smart contracts. Solidity has a number of variables called block variables, and we don't have blocks in Hedera Hashgraph. So how do we deal with it? So, for example, we don't have a block.miner, or we don't have miners. We don't have the notion of block complexity. We default those values. So anything that's block.something will be defaulted to a fixed and constant value. So there's no variation. It won't be a random value because that wouldn't make sense. But the only exception to that rule is block.timestamp, which will contain the consensus timestamp for the transaction. Otherwise, yeah, as I said, everything will be defaulted to a fixed value. So Solidity codes can just run without modification. However, if you do calculations on block complexity, for example, then that calculation will always return the same result because the block complexity will be 1 or 10 or a very high number. I can't remember specifically, but the calculation will always return the same result. One additional piece of information there is message sender represents the account paying for the transaction. So when you run a smart contract function, if your code refers to message.sender, the account that's paying for the transaction will be used to pay or receive currency as a message sender. Addresses. Hedera being different, you know by now addresses for accounts and smart contracts are in shard, realm, and ID formats, each of which is up to 64 bits in length. Last I looked, Solidity uses a 160-byte string, which clearly won't work. So we're catering for this particular discrepancy or difference, if you want, through a property of an account and a contract called contract account ID, which you can get from crypto getinfo and contract getinfo. And this will give you a Solidity compliance mapping of the Hedera Hashgraph ID. So we generate that contract ID for you, and you can then use it in subsequent calls or functions to refer to an existing account or contract ID in your smart contracts. Emitting events. Typically on sort of existing blockchains or other blockchain platforms running Solidity, smart contracts can run or can emit an event that will result in some data being recorded on the blockchain. We don't have one of those. We record those events, or we will. I don't believe that's currently operational, so to speak. We will record those events as records and keep them for 24 hours. So there will be records against a smart contract, and just like there is a get crypto records, there will be a get contract records, which will return you all the records that have been created on the smart contract for the last 24 hours, or in the last 24-hour window. So that's kind of a rolling window. Alternatively, when mirror nodes are available, they will be able to provide pub/sub services similar to what we see with the likes of Etherscan, where maybe you can say, I'm interested in this particular smart contracts events, and they will notify you one way or another of events in near real time, rather than having to query the network periodically for those records. Sorry. So the create transaction for a smart contract creates an instance of a given smart contract. It takes in a file ID, which is the ID of the file you've previously created on Hedera, containing the bytecode. So the process there is that you compile your Solidity to a bytecode, or you get the you compile your Solidity code to get the bytecode for this compiled Solidity. You create a file on Hedera containing the bytecode, and then you specify in a create transaction for the smart contract the ID of the file you've created. You optionally specify the administration keys for the smart contract, the gas that's necessary to construct it, if necessary, an initial balance, again, if the smart contract is payable, and constructor parameters. So if you're creating an ERC20 token, you'll probably need to pass it a name, a token name, and number of digits. So you can construct a Solidity list of parameters for the constructor and supply that to the create transaction, which will then pass that on to the smart contract for construction. So in the SDK, there's a bunch of the Java SDK. There's a bunch of examples for smart contracts, and literally all of the parameters for calling smart contract functions, the coding, decoding, and so on is all based on existing libraries. There's no secret sauce there. It's just plain standard Solidity compliant stuff. And obviously, you can specify proxy details, auto renew period, shard around, your admin key coming soon for creating a smart contract. The same applies as for files and accounts. A call transaction allows you to execute a smart contract function. Again, that's subject to consensus. So the smart contract function or the call will be run by all the nodes, and they all come to consensus. It requires a contract ID, the maximum amount of gas you're willing to pay, the amount of tiny bar being sent in the function if it's payable, and again the function parameters in the Solidity format. No secret sauce there. So all reasonably straightforward. Update transaction allows you to update properties such as expiration time, proxy details, and auto renew periods. I guess this all makes sense to you guys. And then subject to the admin key being set, the admin key can be changed and the file ID can be changed, presumably so that you can change the bytecode that's running. But I would, well, it's not available yet. I'm sure there will be plenty more detail around that when it is. I'm not entirely sure how you go about changing the bytecode of a running smart contract. If it's fundamentally different to what the smart contract is running, then yeah, I guess maybe it's a smart contract reset. I don't know. We'll see when we get there. Queries on smart contracts. So call local, get bytecode, extracts the bytecode for a given smart contract, allows you to verify that the bytecode is indeed what you've been told it was. And get info gets you all the smart contract properties. So looking at it from a protobuf message point of view, contract call transaction body, the contract ID, so that's the shard, the realm, and the contract number, the amount of gas, the payable amount if the contract is payable, and a byte array of function parameters. And sorry, that's it for smart contracts. I haven't spotted the next slide. We're coming close to the end, so just bear with me for a few more minutes. We're nearly at the top of the API mountain. So receipts and records. Again, fundamentally, we don't have a blockchain to store information in, so Hedera approaches things slightly differently with receipts and records. Essentially, the onus is on whoever ran a transaction or created an entity, be it a file or smart contract, or ran a crypto transfer transaction, to get proof that that happened if they've ever feel the need to prove it in the future. So a bit of a crystal ball is required here, but you will not be able to go back to sort of mainnet history 2 years from now to validate the particular transaction occurred. Maybe a mirror node will provide that service, but Hedera Hashgraph will not do that. So if you're paying for something or doing something of significance that you feel you may need to prove later on, there are a number of ways in which you can do so. The first one is a receipt, and frankly, that's not really proving much, other than consensus was reached for a given transaction. So receipt is usually is more a my transaction ran, it reached consensus, or no, it didn't, and it contains the necessary information to error codes and so on to help you figure out why. Hedera will also generate a free record, and a free record, and this is new, this is not currently available on testnet or mainnet. A free record is automatically created with any transaction that's being run. So you remember I said that there's a generate record flag on running a transaction. If you don't set it, your transaction will have a record automatically generated anyway, but it will last for 3 minutes and it will be free. So if you, on the other hand, want your record to last a bit longer than 3 minutes, you can specify in that transaction request that you want a record. So you're forcibly saying to Hedera, give me a record, please, and that one will last 1 hour when it's requested as a transaction option, and 24 hours otherwise. So I referred to smart contract events and thresholds on accounts. Those will last for 24 hours. But if you forcibly request a record for a transaction, it will last 1 hour. And there's also a fee for requesting that record. So what a record contains is a transaction hash, a consensus timestamp, the transaction ID, the memo, the fee paid. It's your entire transaction by and large in that payload, and you can optionally request it with a state proof, which you will be able to decode to get an equivocal proof that this ran on Hedera Hashgraph. Yeah, and fees apply to records. So let's look at a record in a little bit more detail, or receipt and record even. Get receipts has a header and, sorry, that's the receipt response, sorry. So it doesn't contain a great deal of information, except that it would normally contain, I'm not sure that's a good example to be fair, it would normally contain the result of your consensus, was it successful or not. A record, as I mentioned earlier, has, there you go, here's a more complete receipt. Status success and the account ID in this case that was created for a crypto create. So I'm not sure why it's not there on the left hand side. The receipt part of transaction record should, I think, be on the left hand side. The consensus timestamp, so when was consensus achieved on that particular transaction, the transaction ID, and the transaction fee that was paid. So This gives you more detail and it is closer to sort of a proof of transaction being run than a receipt, which is literally just an okay, not okay. And the state proof that we will be able to get along with a record or any entity in the near future will be cryptographically secure and provable versions of these. So just to finish, transaction and query life cycles. So I've mentioned this before. A transaction is sent to a node. The node passes it onto the network. Consensus does happen or not if there is a problem. For example, you're trying to transfer 10,000 tiny bar to somebody and there is no coin in your account. Well, the consensus will not happen. The transaction will get rejected and will fail with an insufficient balance. And the result of the transaction running successfully or not is available from any node. A query is sent to a node, and the node responds to that query synchronously. So let's look at the life cycle from a kind of a sequence point of view. So as a client, I build a transaction body, I sign it, and I submit it to a node. Fairly straightforward. The node will then perform a pre-check, and that pre-check essentially validates things like, is there enough are there enough funds in your account paying for this transaction to execute the transaction? Is the transaction well formed? Are all the signatures included? And so on and so forth. So that pre-check is just a sanity check, if you want, before sending it to consensus. And saves running unnecessary transactions on, or running transactions unnecessarily on the network. If so the node then responds synchronously with a response, which is your pre-checked response, which could be okay or failure. In the case of a failure, then you have to rebuild your transaction, re-sign it, resubmit it, get a pre-check and get your response and so on and so forth. But ultimately, it will be successful, right? So the pre-check will be okay. The node will respond back with a pre-check okay, and will also send it to the network for consensus. So the transaction is then ordered. So this is the virtual voting taking place. The transaction is applied to state, and a record or a receipt is created. And this happens in consensus time. The bottom arrow shows you the entire duration of your transaction or the entire life cycle of your transaction, and the smaller arrow, which may actually arguably be the slightly longer one in terms of actual time, is the consensus time, which is the latency of 3 to 5-7 seconds for the transaction to reach consensus. So at that point, your transaction is run. Your cryptocurrency has been transferred, your file's been created, and so on and so forth. But you need to know for sure. So as a client, you would construct a query. You would sign that query. If the query has a cost or a fee associated, it needs to be signed by the paying account. You would submit the query to the node, which will again pre-check it, verify that all the keys are there, all the signatures are there, there's enough balance in the account, and so on and so forth. And it will respond back to the client saying, yeah, your transaction, or here's your record, here's your receipt, here's your record with state proof. Whatever was asked for will then be responded to synchronously to the client. And that's the query lifecycle. Okay, one last slide and I will let you go. Or I'll take your Q&A rather. So this is slightly out of date as it happens because not all the APIs are there. This was just to try and to show, I'm not sure how readable it is, this is trying to show that there's a world of crypto APIs if you want, and you need to create an account before you can update it, delete it, add a claim, and once you've added a claim, you have to add a claim before you can delete one. It's all fairly straightforward and obvious, all of those that you've run as transactions can then get you a receipt or a record, so you can get a get receipt or a get record in the middle. But more specifically, if you want to create a file on Hedera Hashgraph, you need an account in the first place. Well, you need an account to pay for the file creation. So you need to have an account with HBAR or TinyBar in balance in order to create the file. So once you've created the file, you can obviously delete it, you can append to it, you can update it, and then you can do get receipt or record on those operations. And then finally, in the world of contracts, to create a contract, if you remember, you need to have a file containing the bytecode. So that's what this arrow from file to contract is trying to show. And then once you've created a contract, you can update it, you can run calls or local calls as queries and so on. Right, that's it. So now it's over to you. I hope this was detailed enough. I hope this was instructive, useful. And I hope that with all that information, you're now armed with everything you need to go build stuff.